All right, hello everybody. Welcome to this quarterly Top Product Features webinar. My name is Greg Brown. I'm the head of the product group here at Onshape, and I'm joined today by Cody Armstrong. Cody, do you want to introduce yourself?
Hello, my name is Cody Armstrong. I'm the Director of Technical Services here at Onshape, and I am really excited to be diving into the top features. So let's get things started. Go ahead, Greg.
Yeah, absolutely. So let's have a look at the agenda. It's pretty simple here today. I'm going to have a few words around Onshape and, like a quick look back at 2021 in terms of the kinds of releases that we had and how things work, a little bit of behind the scenes, a little bit of that for how things work with Onshape. Of course, though, the topic of this webinar is to focus on some of the recent things, some of the recent features as highlighted in the blog posting, which probably is the thing that brought you here today. It's not exactly raindrops and roses and whiskers on kittens kind of favorite things, but maybe some of that. Certainly some of the top features that we'll be talking about today are some of the ones I really like to demonstrate. And speaking of demonstrations, both of us will be doing demonstrations for these 8 top things. And finally finishing up with a bit of a Q&A session. So with Onshape, one of the most unique things about Onshape is how often we can release new things to you, our customers. We're really proud of that fact, and it's one of the hallmarks and tenets of being an agile platform that we are building ourselves on, and hopefully giving you the business agility to do your the work that you need to do. Specifically, we actually released 17 times in 2021. And that's actual product releases. And of course, the good thing is that you don't really know that we're doing it other than that little in-app message that you get saying, hey, welcome to release 139 or something. 17 releases is a lot. It's probably a lot more than you've been used to in sort of desktop installed types of software. But in fact, 17 releases isn't the only times we put new code out to you. I think, Cody, I don't know how many times that we would deploy new code during the year. It's a lot more than that, in fact, isn't it?
Yes, many more times than that. I would say just on average, we update the code base probably every few days with things that aren't necessarily all improvements, but bug fixes and things like that. So Onshape itself is constantly evolving.
That's important to note that we're talking about real releases here with new functionality and everybody being on the same level and having documents updated automatically. You just log in and enjoy the new features. So I'm not going to go through this slide in any great detail. It's a bit of an eye chart, and this is really only a subset of things that would fit into this particular slide. Some of the ones that we will talk about today are actually highlighted over here. And let's have a little bit of a look at those top 8. These ones that we chose to highlight in the blog posting that came out the other day, and hopefully you've all seen that. If you haven't seen the blog posting, there's the link to it. It might be a little bit hard to copy down. But if you go to onshape.com, you'll be able to easily follow this through when you find the innovation blog post. So really briefly, there's going to be 8 things that we talk about today. Starting with the IP tracking dashboard. This is something for enterprise users, and it really highlights some of the real benefits of being a cloud native application. The sorts of telemetry and data analysis that you can do is simply not possible if you have a desktop install type of application. Release management. Release management is really a really cool part of the integrated data management that's part of the Onshape platform. Of course, you don't have to install, or you don't need to install a separate PDM system in order to work with Onshape. It's all in the Onshape platform. One of the key differentiators and key sort of revelations when you move to the Onshape into the Onshape user community. So change detection in that is a new, in addition to the existing release management capabilities.
One thing I would add,
Sorry, yeah.
Sorry, Greg. One thing I would add is you'll see that throughout this, we're really trying to emphasize the things that are unique about our architecture and things like that. And so you'll see in almost every one of these, not just that we've done them, but that we've done them in a way that's very much Onshape in its form and how it works. And so there's unique aspects of everything you're going to see here in terms of how it's implemented. And that's one of the things I'm most excited about. Is not just showing you these things, but explaining why they can change your workflow, why they can change your day-to-day. So, sorry, go ahead, Greg.
No, that's a great point. There's some things here, not the first couple, because the first couple are truly unique and in the industry, but some of the other ones, you may, there's not always the brand new, but the way that we've done it and the way that, as Cody said, the way that it can influence and enhance a workflow is kind of, that's the unique aspect that's built on the Onshape platform. And parametric replicate is one of these things that people have been patterning things for years, right? You can do it many different ways, but the way that we've done it and the way that we'll show you how it works is pretty cool. Sheet metal fold orientation. There have been some improvements in sheet metal as well. We have a unique and very powerful sheet metal capabilities in Onshape. We're continuing to build on. And similarly with ruled surface, ruled surface is a fundamental way of creating surfaces in any CAD system. And we've added that capability into Onshape as well. And really what it does is it builds on a real growing and strong base of surfacing capabilities inside Onshape, which may be surprising to a lot of people that we are so powerful in that area. So stay tuned. I think Cody's got a good demo for that. Similarly with drawings, drawings are also a big fundamental part of any CAD system, of course. It's where it all came from. And so being able to produce production drawings at the sort of the quality and the level of the expectation that people have got, is a continuing theme for us here. And one of my favorite ones that I really like to demonstrate is this next one with mates, and particularly with ball mates and the new limits that you can put on them. But there's a bigger story to how we use mates in assemblies in a unique way in Onshape as well. And finally, there's something that I think the name of this, Cody, is hiding something pretty special, isn't it?
Yeah, it's a very indescript name for it. Once you see it, you will see it's truly. I honestly think this is my personal favorite of all the things that we're going to show today, and I think it's one of those things that's really revolutionary in terms of how you communicate engineering data. And it sounds like a very high level thing, and it is, but it's a huge impact on how you collaborate. And that's something we excel at in general, and now we're just getting better and better. So.
Yeah, I like this idea that we're unveiling some of these powerful benefits and differentiators, bit by bit, so that and finally this one is a good finale for the little webinar that we're having today. So enough talk. Let's actually demonstrate some of these things. So I'm going to shift over to my screen here, and I'm assuming that everyone can still see everything. And we're going to talk about the first one that was on that list, which is IP tracking. Now, just as a background to this, analytics is a fundamental part of the Onshape Enterprise platform, because anything that you build as a cloud native true SaaS tool is going to have unique benefits and capabilities and opportunities to have insights into the data. We know a lot of, we can put a lot of telemetry into things that, again, as I said before, is not possible when you have a desktop install that's based on files. So here I've actually got an audit trail of IP tracking. This is the new dashboard that we added in the last quarter. This is a really powerful one, and I'll just take you through some of the things that are on the screen right here. So I've actually got this running just to look at the last 60 days of my enterprise being the ptc.onshape.com enterprise. So this would be constrained to whatever enterprise that you've been working in. Obviously, the one that's calling out to me straight away is this map. Now, this is a live map of where all of the logins have occurred, where documents have been accessed. And it's really interesting to see. You can tell that somebody took a vacation at the Grand Canary Islands, but they couldn't keep themselves from logging into Onshape. So that's kind of fun. And you can also see that you know, the logins for this enterprise really span the entire globe, you know, from our office in Tokyo through to people up in, who again were on vacation in a very beautiful part near Vancouver. But of course, you know, this is really just a very, very high level view, just so that an administrator of an enterprise can see if there's any anomalies occurring, and maybe be able to take action on that. Again, this is not something you would be able to do if you'd been, you know, emailing copies of files around and people were using, you know, installs on computers that are uncontrolled. The next little kind of drilling into it is to look at some of the actions that have been occurring. Again, this is about IP. So the intellectual property of my enterprise is really the crown jewels, of course. And I can see down here who, and I know Jay is on my product management team, so I trust him implicitly, but I can see here that he's been doing some exports in, say, step format from this particular document at this time on this date, and even if I wanted to, I could drill into the location he did it from. Now, you know, that sounds interesting, but it would be really interesting if you had certain collaborators you were working with and you had sort of standard operating procedures that did not require any export of data, such in STEP or STL or IGES or whatever format. So again, it's just something to do to monitor what is actually happening to the IP. Perhaps over here as well, as you know, documents have been copied. You know, a new copy of this document was created, and maybe I'd just like to know why. And I can do that very, very easily. So Cody, have you sort of used this in any particular other way?
Well, I think that any application where intellectual property security is the concern, this is kind of the go-to dashboard for it. I think that's where it's highly beneficial. And the thing I always like to stress about this dashboard and analytics in general, but particularly this dashboard, is it gives you insight that really no one else can give you in real time, or a period in some of these cases, right? So documents exported, for example, there's no way of knowing that in a traditional, you know, client-based system, but Onshape tracks that in real time, right? Same thing goes with documents copied. How do you know if in a traditional system that someone hasn't copied your file? Onshape does. And so for administrators, you know, CAD managers, people who are owners of businesses who really are, you know, security of intellectual property is top concern. These things are huge differentiators for Onshape because they give you like that real-time insight. And I stress real-time only because there's no dependencies on the check-in state of files or anything like that.
Right. Yeah. I mean, I guess it's one of the things you said earlier is that if you start, you know, once you start to get this, you can really fundamentally transform the way that you're doing your business rather than just slotting in this as a tool to replace something else. It's more than that. Right?
Yeah, and from these you can really drill into, like, this is a high level look at things, but you can drill into audit trails that give you very nuanced look at what's going on across the entire organization. So we're often asked the question, you know, especially from the enterprise level, like the administrators or CAD managers or, you know, managers in general, is can you show me everything that's happened, you know, across the organization and allow me to filter through it? And that's essentially what that is. So
yeah, I'm not going to go through all of these now, but you can see here, other than the audit trails, you know, there's information specific to release processes or projects or users or, you know, all sorts of things like that. So, you know, the one, you know, today it was around IP tracking, but the big picture is much bigger.
And I think the IP tracking really emphasizes something that we're uniquely fitted to do. You know, we can tell you all that information and give you true insight into it. Not just who did it and when, but where, you know, what project was it in, those kinds of things as well. So,
and speaking of unique, let's go to the next one. So here's an assembly that you may have seen before that I've used probably back in the Onshape Live conference, but here we go. So when we do, you know, it's not just about creating shapes and pretty pictures in Onshape, it's about getting work done. And part of getting work done as an engineer is releasing things. So having the release process that's built directly into Onshape is an amazing advantage over the way that you probably had to do it in the past. So you see here, I can just release this assembly and I can choose from different release workflows that I've got set up. I've got a couple of different There's a 2-tier approval, and this one's just a simple one. Anyway, that's not the big focus, is not on that. But the big focus is when I create this release candidate. Now, a release candidate is like a package of data, and it's not a package of files, or it's a packet of objects, and objects that exist in the Onshape world, and it's gathering them together as we speak, and it's going to do something really nice and unique with that. Oh, well, by the way, when you create this release candidate, you can add things which aren't CAD documents and CAD parts. We can add additional things that are in the Onshape document, like drawings or whatever else, associate them to this release candidate. But anyway, looking at here, what it's giving me is some really interesting commentary and guidance. So this first one, it says that this tab, or the element down here where this assembly is living, has an open task assigned to it. So you probably better go read that task and see what that comment is asking you to do. But the really, really cool one, and the one that is the focus of the latest release, is that we actually can do geometry change detection as part of this. So it's telling me here that this carburetor body needs to be revised, right? So it's going to go up to level J. But the one below it, the slide that's inside it, it says the item geometry has not changed since its last revision. And therefore, it gives me this choice to revert that to its last revision. And so I can just keep it at H in this particular case. And that's pretty cool, because it's not going to force an unnecessary revision on me and into this whole process. And you can keep going down. You can see that some of them have changed, some of them haven't changed. I can revert all of them if necessary. I just want to revert all of these unchanged items back to their previous revision. And this is something, the ability to do this geometry level change detection as part of release is unique to Onshape, because we're not merely looking at a timestamp on the last time the file was touched. Of course, because we don't have any files here. These are objects, and we know exactly what's being done. What do you think about that one, Cody?
That one to me is the most compelling. The most compelling point of this is just the sheer nature of our architecture means that this is done in a very different way. Like in most situations, the systems, you would have the timestamp, as you mentioned, last modified as kind of the trigger for the thing that notifies that something has changed, but it's not looking at individual features or geometry to determine if there are changes. And so we can actually delineate between the two. You'll see that properties have changed, geometry hasn't changed. You'll know what those things are. And so it's a really compelling thing. I think that it's the reason that I think that it's most beneficial is, in my experience, there's a lot of frivolous up-revving of things just because of small changes to a file metadata that doesn't warrant it, right? But you have to trigger that notification anytime you change a file, period. So,
it's simply too hard to work out otherwise. If you don't have this automated way of doing it.
Yeah. So this is one of those areas definitely where we've used our architecture to advantage. True geometry change detection is a unique aspect of our release management for sure.
Sure. Okay, so there's a lot more we can talk about with release management, of course, but for the purpose of today, let's move on. All right, so here is a very simple assembly, and what I'm going to do is attach this stick or whatever it is. I'm going to attach it with a mate. All right, so I'm going to use a ball mate. So I'm going to attach that down here, and you'll see that is now mated. All right, so we have an assembly, and I can move this around. Blah 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 blah, and I'll reset that one so that it stands up nice and straight. Right, I'll go back to the part studio from whence the plate came, and I'm going to uncover that there was a pattern for this feature. All right, so I'm going to uncover that. And so I've got a nice 2x1 pattern. If I go back to the assembly, of course, the pattern appears. Now, the idea with parametric replicate is that if I choose that instance, and it's going to ask me find the parts to try and match in. All right, so I mean, I didn't really have time to explain what was going to happen because it's pretty obvious. So that is interesting, and these are actually two separate mates because they because it replicated the mate as well as the instance there. And you can see here there's a replicate item in the tree, and I can access the mate for that as well. I guess what's really cool now, if I uncover that there was a variable controlling the size of this array, and maybe put 81 of these guys in instead, then magically or parametrically, which is really the same thing in a lot of cases, there we go. So that saved me a lot of work. So I can fiddle with each of these tentacles or whatever they are individually. I keep thinking of those gift shop kind of toys where you put your hand through and get a print on the other side. So that would be a cool example to do. But this is kind of what I could come up with in short form. But I think Cody, you might even have more to offer on this topic.
Yeah, I mentioned this to Greg. This
Yeah.
is one of my personal favorites. So I'm going to show my screen. You should be seeing it. So this is one of my personal favorites, and there's a few areas that I think this is really applicable. It's a huge change if you do a lot of assembly level patterning, obviously, and non-traditional patterning, non-linear, not linear, not circular kind of patterns in areas that are not typical. And that's where I think the key applications are, and they're taking it one step further. I think that the application for this that I think is really killer is configurations. And the reason I mentioned configurations is because in the past, the replicate was a one and done thing. It was not parametric, so therefore it didn't regenerate whenever the model regenerated, which is a thing when we start talking about assembly configurations, right? I want to be able to build in configuration on the fly and know that the bill of material is accurate and so on. So what I'd like to show is an example of how this applies to configurations. So here I have just real simple mount. All it is just a bracket with two pieces. And the idea is you have several different motors in here that this thing holds. And so you have different variations of this. They have 5-pin variation, you have a 6-pin variation, and you have a 7-pin variation, right? And these are just pins that are manually laid out using sketch points. So there's no linear patterns or circular patterns. They're kind of randomly located wherever the motor that attaches to them mounts. And so you have these different variations of this bracket, and you have a length variation because the distance between the attaching geometry can vary in an infinite capacity. So this is where we take advantage of Onshape's configurations, right? I can literally have an infinite possible combination of configuration sizes. Where this proposes a problem is when we start talking about the assembly level and all the things that go into this, right? I want things like an accurate bill of materials for, maybe it's purchasing or whoever it may be. Those things are really critical. And so the application I was thinking of is, well, in these scenarios, replicate is really the most powerful tool now because of the fact that it's parametrically linked to the underlying features. And so here's an example. It's the same assembly. I haven't built it out yet, but this is the same assembly with configurations, 5-pin. It's just calling up the same variations of the part. But the question I wanted to put forward is, what about hardware in this example? Or what about just anything that you replicate that is dependent on underlying configured geometry? And so in this example, what I'd like to do is just give you a taste of what I think this workflow would look like. So in this case, I'm just going to insert a piece of hardware. Bear with me for a second here. We will drop that in, right? And then what I want to do is, of course, I want to replicate. So I choose replicate, right? I choose my instances to replicate, pretty straightforward. And I choose the matching face, right? The face to find matches in. And in this case, it says match faces in this part, in this case, the top plate. And so what you'll find is it's replicating, of course, that standard content instance to every single instance or face or hole in that face. So it's traditional replicate to point, right, to date. What's different is how it looks and behaves. So in this case, we have, the countersunk head flat screw, right? We have replicate for each of the instances, and that's really what's unique about this. This is now an item in the instance list of the assembly, and it's a real feature rather than just being a true replication of all the geometry associated with it. And the power of this is in how it regenerates. So if the underlying features, the underlying faces change that drive them, this will update parametrically. And that, as I mentioned, I think the real power here is when you go to change configurations. Because if I go from a 5-pin configuration to a 6-pin configuration, what you'll notice is the hardware is automatically populated. And that's the key, right? Because I may have a million of these configurations, and I need to be able to generate them on the fly and know, most importantly, that the bill of materials is accurate, right? That I have the accurate part numbers and descriptions and instance counts of those kinds of things.
Yeah, I mean, it just spreads from there, doesn't it? I mean, the configuration power you've got, when you start talking about in getting into the bill of materials and into the configured assembly properties as well, you could be automatically changing the names of things. And
that's really where the power of this is, because it allows you to take those assemblies that were, replicate in the past was a one and done thing. It wasn't parametric. So you would always have to go back and manually change things afterwards. But now you can be assured in this kind of workflow that no matter what configuration is generated, that the replicate will push those changes to the to that configuration. And so, in my opinion, this is definitely one of the coolest modeling updates that we did. It's one of my personal favorite features in general, and now that it's parametric, it's even cooler. So, really exciting.
Yeah, absolutely.
So the next one I wanted to go over is the sheet metal fold orientation. And this is one you'll find a few that are really just the next two, actually one and the last one that I'm doing here, are really just quality of life, big quality of life improvements. But we know how big those can be for our users. And this is one of those examples where it's a simple change, but it's a huge thing for those that are doing sheet metal fabrication. And that's a big part of our users. So sheet metal, Onshape sheet metal is also, of course, very unique in how it functions, right? We have the Onshape, sheet metal flyout where you get the sheet metal table in flat view. You can always look at the flat view. You can interact with the flat view live in real time. So we've always had a really unique solution to our sheet metal tools and how they work. But one thing that's always come up is how we display those sheet metal parts in the drawing level. So the drawing level, you have your sheet metal flat view that's inserted, and you have your bend notes that are defined. And in the past, the bend notes and the bend direction, more importantly, was a fixed thing. And so if your part, the way you wanted to bend it, everything was essentially inverted, all of your bend notes would be exactly opposite of what they should be. And this sounds like a small thing. All you're doing is changing up to down. But when you hand this to someone who's going to manufacture that, it makes a world of difference. Up and down is huge, huge difference. And so, there's all kinds of workarounds and things like that you can do in the past. But the reality is that, we needed a way just to say, flip everything around, right? So that the bend directions are the opposite. And so in this case, what we have, if I go into the sheet metal model, you'll notice this new option to flip direction up. And just like the name implies, if I hit flip direction up, it flips the direction of the normal direction of the actual sheet metal model. And in the bend notes, most importantly, you'll see them flip, right? Of course, we update and let it regen, and you'll see those bend notes will of course update. So a very small change, right? Just that all we're doing is flipping the direction of the normal for sheet metal parts. But if you're manufacturing these sheet metal parts or you're sending them off to be manufactured, and the directions of up and down, that's a big, big deal. So,
and I guess, it's a small change, as you said, but it's one of these paper cuts, kind of, if you have to do this type of thing all the time, they can add up, and we understand that. And in fact, the way that we develop and we make space for this in our development environment, and to be able to deliver these kinds of things on a continual basis, we can stay very engaged with what, the feedback about these kinds of paper cuts really is.
Right, and this is a good example of something that came directly from user feedback, right? From when we shipped sheet metal and we got tons of feedback about how it needs to be used and what changes need to be made. This is a good example of that. So my next feature, this is one of my personal favorites, one of the personal favorite modeling features, surface modeling especially. This is one that so many users have requested. If you do any kind of surface modeling, you'll know where this is useful and where it's applicable. But it's referred to as ruled surface. And it's essentially anytime you need to create a ruled or extended surface off of an edge that's normal to the direction of that forming edge, that curve. And so this example, I have a wireless mouse. I'm just going to roll back here to a moment in this mouse's design where you kind of have just the shell of the mouse. And I want to give you an example of where I might use a ruled surface. So the first example that I think is most common is anytime you need to extend a surface for the purpose of creating like a split, right? Splitting between, a good example is mold design, where you're defining a parting surface and defining cavity and core, and you're splitting between those. I think that's really one of the biggest applications for ruled surface. But anytime you need to extend a surface, off of an edge, and it's not necessarily always just a tangent extension, right? Where extend surface would be applicable. So in this case, I have just edges here, right? I click ruled surface. I say, what edges do I want to define with my ruled surface? I select the surface and it generates my ruled surface. Very straightforward. So it's a very simple command to use. It's the simplest level, but it's one of those features that has lots of depth. So it has lots of features that you can dive into and kind of ways that you can tweak the surface. And that's probably why I like it so much, is just the flexibility of what is generated with it. So let me show you what I mean. Ruled surface type, normal, right? Pretty straightforward. Tangent, can be tangent with the surface's edge, right? Continuing that tangency out. You can also have aligned with direction. There's a number of different applications for this, but I think the big one is, if I wanted to find, again, maybe a parting direction, right, where I have a parting plane, so to speak, I can define that. I can say, okay, this should be normal to like the top, right? And it will define that surface normal with that direction, or aligned from direction, which of course kind of gives you the ability to tweak that based on an angle. But I think the big implications here are, just the ability to grab and extend that edge along any direction that you want, right? That's really where ruled surface applies. So if I were creating, a parting surface along a planar edge where the cavity and core split, I might use something like this to define that, right? Now, there's a few things I like to point out about this. One of the first things I like to point out that really makes it flexible is the ability to override a vertex. So I actually have the ability to click in here and grab each point along the curve that I've chosen, or the edge that I've chosen, and manually manipulate the surface, right? So I can grab and drag this surface and pull it back, right? And so if the twist isn't just right, or if it's twisting too much and you need to pull back the surface a little bit, you can grab and manipulate the surface manually. And that to me is one of the neatest things. And it's not just the ability to rotate, it's also the ability to extend the surface out further or pull the surface back. You can grab the arrow and do both of those things. You can even transition between different ruled surface types in each of these transitions. So really cool. The flexibility, the ability to grab and manipulate that surface is something that's been highly requested. This would have been, prior to this, you couldn't really do this with a sweep. It would have been a complex thing to do with a loft. It's a few clicks with a ruled surface. So that's what really makes it the most powerful. There's lots of applications for this in surface modeling, construction surfaces, lots of we've had customers who like to define their draft using a ruled surface, and then they can manipulate the ruled surface and it varies the draft, and they have this nice continuous surface to derive from. So lots and lots of applications for this.
And Cody, while you're on that, I think this one feature, packs a lot of punches into it. Like there's a lot of power in that one feature. And then, just running my eye up and down the feature tree, you've got there's a lot of other interesting features in Onshape for very powerful surface modeling. In fact, this mouse does demonstrate a bunch of different ones of them, right? Bridging curves and so on and so forth, and there's the lofts as well.
Yeah, bridging curve, fill's another really big one.
Yeah.
So this is an excellent example of kind of our suite of surface modeling tools. And I think the ruled surface really rounds that out. It was a big request for a long time. And now not only do we have ruled surface, but the ability to tweak it manually and the ability to go in and grab and pull and do things like that. Really, those would be many steps in many traditional systems. And so we really built it in an intelligent way that I like. Now, one thing I would add to this is just a small tip that I have, but it's particularly useful, I think, in ruled surface, just a random tip that I always like to point out. But I really recommend, this is something that not a lot of people think of, and I've seen it time and time again, using things like create selection. This is something we've had for a long time in in the selection, and also built into a number of different tools in Onshape. But if you use, you're in a situation where you need to select a lot of edges all at once, right? What I could do is just right-click, create selection, grab edges, tangent connected, and then just select one edge, and it will grab all of the tangent connected edges. That's a big deal with ruled surface. The only reason I bring it up is it makes it a lot easier to work with.
Yeah.
You can easily grab all those edges, especially in like parting surfaces where you need to grab, dozens of edges along the profile of a part. You can do that easily. So great selection, just kind of a random tip that I think is particularly useful with rolled surface.
It's a random tip that applies many places through Onshape, and I hope you've enjoyed that bonus tip for the day. Yeah.
All right, so my last one here today is conjugate dimensions. And this one I think is really another example of a quality of life change that is huge for drawings. And we all know drawings are about the details. Getting the details right at the drawing level is really what it's all about. And this is just a simple example where angle dimensions could be tricky in the past if you wanted the dimension to be a certain way, appear a certain way. And so in this example, what if I wanted an angle dimension that was, different than what the default gave me? If I go to dimension, I select 2 lines, for instance, I get this dimension, but I don't get any kind of conjugate or alternate forms of that dimension. So we are often asked the question, well, I don't want this dimension that's there by default. I want the very form of that. And so in that situation, if you go to line angular dimension, you do a line-to-line angular dimension, and you select 2 lines, what you'll see is it does allow for that conjugate dimension. And so again, a really small thing, but a huge difference for those doing drawings all day long. If you're doing these kinds of drawings all day long, you know the pain associated with manually having to move those dimensions around and re-reference them and so on. So this one, again, quality of life, but drawings are all about the details, and I think this will be a very important one. So that is what I had planned. Greg, I'm going to pass things back to you.
Yeah, I'll just grab it. And I think that we should be back on my screen. So yeah, just to finish out the demonstrations here, let's move to another one of my favorites. Right, so here's a pretty nice model that I've been working on a little while. And if we look inside, this one has quite a bit of work done on mechanisms. It's kind of the favorite part of it for me. All of this is put together with mates. We have full kinematic representation of the four-wheel drive mechanism and everything else that goes inside. If we have a look at the front right corner of the suspension, the interesting thing here is that there's a bunch of ball joints, right? So if I move this, it's been assembled with a ball joint. If I move this around, it's actually going to be it's going to do some unnatural things. It's going to do some unnatural things, and because its limits aren't applied. So that's something that we have addressed in this latest release, or a couple of releases ago. In any ball joint now, or in a mate here, which is the ball type, you can add a limit. All right, so I'm going to add 30-degree limit to that. That's going to stop it from flying around and doing an unnatural, unphysical type of thing in the future. And what this actually has, a couple of things that this does. It keeps your model much more physical, but it also helps that when you're assembling it, when you're doing something that's very complicated like this full top-level assembly, you don't want things to snap into maybe a 180 degrees out kind of a configuration, and it helps to be able to keep things closer to the solution. And having mates in there is a good one for that. Obviously, the length of the shock absorber also is controlled by mates, mate limits, and that's also going to help my assembly here. Now, there is if you did a mate limit on every one of the 300 mates or something, whatever in this, it might be too much for it. There are performance implications, of course. So my bonus tip for today is how do we know how many you've got, and where do I go to look, and how do I ask that? Well, I'm glad you asked, because there's a very good place to look, and that is the performance monitor over here. If I hit the performance monitor, it actually gives me some really interesting things, aside from the obvious ones around network and system and graphics performance. I'll get back to that in a second. But up here in the top, we can see the mate solve time. And down here, I've got 32 mate limits. So there's 32 mates somewhere in here that I've been working on just for testing purposes. And knowing that number is actually can be very, very useful. when you're diagnosing and doing other things with performance. The other really interesting thing in this view here is with graphics. And I saw this on the forum the other day. Someone was asking about how do we know if there's a very fine tessellation. In fact, you go to the same place. You go to this performance monitor and pull down here. And if there were any very fine tessellated parts, it would say that you've got one very fine tessellated part, or 2 or 10 or whatever. So yeah, there are ways to do that. And for whoever, if the forum poster is on this call, then welcome and thank you for joining. But also there's your answer. So I did want to show you this because this is my favorite model, right? I'll go into no perspective so that you can see the mechanism here. And in fact, there's also a floor which I'll put on so you can see the ground plane. There it is. Right, and it's very, very highly configured, this model. It's configured in every possible way that it can snap together according to the suspension setup that you want. And I can even change the ride height, just by changing that configuration variable. Again, this is, a configuration variable that Cody was kind of showing in his demonstration earlier. And in this case, what it's doing is it's having to solve the kinematics of this very, very large, kinematic problem here. So that's a kind of exciting thing that I can then evaluate the camber angle changes and all the other cool stuff like that. So Onshape and mates in assemblies in conjunction with configurations, and now these limits on ball mates, it's pretty powerful stuff.
Yeah, to me, the biggest thing here is the ability, like now ball mate has always been pretty efficient, and there's one mate that constricts down to 3 degrees of rotational freedom. So it's one mate that does that. And that's a pretty powerful thing. It's kind of the nature of Onshape mates is they do that. But what's really neat here is now it's one mate that not only restricts it down to 3 rotational degrees of freedom, but it restricts the motion within that. And that's
you're right. Yeah, that's a particular power and difference of Onshape in that people, sometimes take a little bit of getting used to, that you don't need 300 mates anymore. You might, need 30, right?
Well, when we talk about performance, think of the performance implications of going from 3 to 1 in terms of mates, and then having to define mate limits as a separate thing on top of that. It's really powerful to be able to put it all in one single package, and I think very intuitive because it just makes sense.
Now, before I move on, I just wanted to point out to people, if you do have any questions, and you haven't already been using it, it's a bit hard for me to see while I'm demonstrating with the full screen here. But if you do have any questions, there is a facility in the GoToMeeting or GoToWebinar user interface. I think you can post a question there. And even if we can't get to them all by the end of the time allotted today, then at least we'll have the questions documented, and we'll certainly be able to get back to you with any answers. All right, but we're actually nearly at the end. We're at the number 7 of the list I think was this one, and we're pretty close to the last one. So if that is the case, then I will move to that last demonstration. And what I'm going to do is actually move to a different browser, and I'm logged into Onshape as a different user now. I'm logged in as a light user and who doesn't have edit role in their permissions. This is just to show you something a little bit different. Now, of course, we did release general tasks recently, right, as well, which is not on our list, and it's a pretty cool one, and we probably would have put it on the list had we released it in time for the list. But I can talk about it a little bit now. Anyway, action items as part of getting things done, and typically up until recently, action items were linked to comments that you made in your documents. Like, I can @ somebody, I can attach a tag to some part of the geometry in the document and say, can you please do something to this? And it sends the action item and it delivers it into the destination person's action item list. And I'm seeing action items assigned to me. And there's one here that says, please review the assembly and the exploded view here. And I'm going to click on this link, and you're going to watch something happen that's pretty cool. What it's going to do is it's bringing me into the document as specified in the comment, but it's done a very, very special thing. and maybe you've already can see. What it's done is it's assembled it's showing the document in the correct view. The model's in the correct view. It's in the exploded state as defined. The panels are in there, the user interface for the panels are in the certain state, like it's hidden here, and the bill of materials is shown over here with my special commercial off-the-shelf vendor BOM that I've specified. All of that happened and was encoded in one single URL. And that's really, really, really cool, because that one URL that I could share that in an email, I could post that in a Slack message or whatever, and whoever gets that link doesn't need to install anything, doesn't need to open a file, download a file, install an add-in using a different app. They're just using the same web browser as before, and they're going to exactly the specified view, orientation, exploded state, BOM state, everything, and more. There's more than that. You know, I can now manipulate this because it's still Onshape, right? I can turn back on that panel, but I don't have edit capability. I have edit rights for this document, so I can keep that turned off. I can turn off the bill of materials and do interesting things as my task as a reviewer might need me to do. Perhaps measure. I'm going to check that that is actually the 42mm bore as expected, so that's good. I could do some mass properties and set up. Maybe I need to set up a following session with somebody else who wants to talk me through something here. So let me just go back and I'll show you kind of how that again, magic works. All right, so I'm back here as the creator of this, or the owner of this document, or the editor of this document, and I can specify, a different configuration perhaps. I'm going to specify the large fuel injectors and this crazy-looking dual funnel setup that I was experimenting with that may or may not have any performance benefit. Anyway, and I've also got it in a particular version. So I've picked version 13 as what I'm looking at. Now I'm also going to specify my things like, show it in the exploded state, show the bill of materials, put this thing in the particular orientation that I like, turn off the panel. Now all I do is I say link share and copy that link to the clipboard. I'm done. All right, that's linked. I don't have to do any downloads, exports, or anything like that. So just to show you how that link would work, I'll just paste it here and see if what I was saying comes true. All right, so already I can see I'm in the correct version. I got my bill of materials, I've got my view states, and everything's good. So this is kind of a revolutionary way, and a completely unique way of being able to share IP. You're not getting rid of any IP, you're sharing your design, you're collaborating your design, but there's no IP being leaking outside of your environment here. Is that your favorite, Cody? Because that's my favorite. Right?
I feel like you should have dropped the mic at the end when that loaded.
Oh, yeah.
I think that this is by far the biggest improvement in my mind, just because of the implications of it. It's very easy to focus heavily on engineers because that's where we work with day in, day out, but engineering data has to go somewhere, has to be communicated with others, and how you handle that is really cumbersome today. You mentioned it briefly, but you'd have to download an executable, right? Make sure the executable matches the file you've been sent, right? Download the file. This is all coming via email, which is not a great security practice, right? To download executables and install them off the internet or frankly anywhere else. But and then you'd have to explain to the person, install the executable, open my file, find this view, open it up. You'd have to explain all of these things, and the barrier to entry is too big for most people to even look at geometry. And so most people just don't do it because of the headache associated with it. But as Greg showed, you can literally just generate a link, click it, and you're looking at exactly the information you care about. And you can generate these links to apply to numerous applications. So if I'm trying to send assembly instructions and I want to see an exploded view, and they can go through the bill of materials and cross-highlight the parts and find the part numbers. And I think the biggest benefit of people who've never heard of CAD but need to interact with the model for whatever reason, they're proving it, or they're working downstream from it, and they're not CAD experts but need to be able to look at the model. That's where I really think this applies, because in the past the engineering data stayed with engineers because of the troublesome workflow associated with sharing it outside. And this allows you to maintain that intellectual security, property security. Like no one else can download this, no one can export it, those kinds of things, which you don't get, by the way, when you send a file. But it also gives you the ability to give you exactly the orientation, the bill of materials, the view that they should be looking at that relates to what they care about.
So if I jump back to this one, and I'll unveil a little bit more, maybe this is a kind of extreme case, but look at how many configurable items there are in this. And what I just did with creating a link applies to the exact configuration. So when I the exact configuration that I want to share to somebody will be encoded in that link. And imagine how difficult it would be to tell somebody who isn't aware of how to use CAD. They might be able to spin around and all of the things, but if I have to make them dig through something to achieve the same configuration, that's going to be a really, really tough call. Whereas here, the exact configuration, I've got my double funnel with large injectors, but the other one that had, possible, I actually added it up in that RC car. There's over a trillion combinations in theory that I could come up with. So it's pretty difficult to do that in any other way other than how we do it here in Onshape.
Yeah, and that's again just kind of coming back to that summary of like we've really tried to highlight things that are very unique to our architecture, and this is a good example of that. Like no one else is really suited to do this and do it so well, and so we can do this in a way that's very unique to Onshape, and I think a real benefit to the users. Like anyone you share with today, if you're using traditional file-based systems, the workflow is very different and very cumbersome.
Yeah. So I think I'm going to switch back to a different screen. This one. Because I think that we've come to the end of our allotted 8 favorite things for the end of this year. I said at the beginning, we have plans to be able to do something like this. I think it'll be very valuable for everybody involved, especially including us on the product side and the technical side as well, to be able to discuss something like this with you on a quarterly basis, I think. And to that end, I don't know if anybody has questions. Cody, have you?
We do have a few questions. Yeah.
Okay.
So, and I'd like to encourage you, if you have any other questions, we have a few minutes here before we wrap things up. So please type them in the questions section in the GoToWebinar control panel. We'll do our best to answer them. So starting at the top here, is there also a release roadmap for 2022?
So yeah, I mean, we have we do things a little bit differently in Onshape as perhaps other traditional software companies. We don't have a waterfall process that's put big stakes in the ground that in October this is going to be released and in December this is going to be released. We certainly have a roadmap that is driving us, and we have very, very strict guidelines and plans around how that would be. We don't tend to share that because things often change. If you want to see some sneak peeks of things, then the Onshape conference, the live conference we have in March is probably the best bet to see that. So that's the general approach that we have. Yeah. But we certainly have a lot of things in mind.
And there's definitely a big, Greg, you can correct me if I'm wrong, a big focus on agility and the ability to kind of shift focus. If we suddenly get a lot of demand in a certain area, we can shift the development resources kind of accordingly. And so we're always trying to match demand and make sure that we have the resources to the right places. So
that being said, we've been working on some big things, and there will be some big things coming out at the same time as these addressing of paper cut types of things. So we balance that. We have to balance between, if we're heads down developing something that's hard and big, then, but at the same time, we still want to be delivering valuable things every 3 weeks.
Right, and I think we've shown an even balance of that here too. Of the things that are quality of life and the big ticket things too, and more of that to come. Really exciting stuff to come.
Absolutely, yes.
So the next question, or I think it's more of a comment, maybe we should call it deep link or target linking. I think this is in reference to what you just showed, actually.
Yeah.
It's not a bad idea. The name needs work, I think.
Yeah. It certainly was it's bearing the lead a little bit, or it's a sleeper. It's a sleeper at best. You know, yeah.
Just rename it to the greatest collaboration feature of all time.
It could be, yeah.
I
Yeah.
love name. I think it'd be good. Can you save a release candidate before you're releasing it? What happens if you close the tab where your release candidate is open? Do you lose that candidate? I think that if anything you apply is stored, so if you close it and come back, it will bring it back. But it regenerates at any time you do it. So I would say that a release candidate isn't submitted until you actually hit submit. And so anything you do up to that moment, unless you hit apply, won't be saved. But I think that's why we have apply versus submit in the UI. Is there a way in Onshape to model soft parts, say a spring with a certain spring constant, and further some limits to the possible lengths of the spring?
That is not an obvious one. I mean, there are workarounds to that. So you're probably asking for what you could call it a flexible part or something. I mean, you can design something in context of an assembly and have its position, you know, be determined by the context it's in. You know, that would be one way to kind of one way to do it. I've seen people do other things with springs, but what I see is people, are you doing it for cosmetic reasons or for engineering reasons? I guess that's the question that really comes to mind. So.
Yeah, I agree, because a simulation is a different thing. If you're going to
Yeah.
simulate deformation, then it's a different process than if you just want to see a compression of a spring at the assembly level.
Yeah.
I think obviously you can model a spring, you know, that's very simple to do, but modeling the spring's compression dynamically with assembly motion is a different.
That is a very different thing. But as I said, you know, we have techniques that people have done and we've done ourselves on getting the cosmetic effect of having a spring. You know, you can have it made up of multiple parts, and you know, hidden behind the scenes there's some things going on. But that's not the engineering of it.
Right.
To be sure.
Yeah. All right. Any movement on the rendering app being released?
Yes. Yes. You know, I suggest people stay pretty closely tuned for that. Yeah.
Stay tuned. We're really excited.
Very close. Yeah.
Can I easily see who I've shared documents with without Enterprise? It's a good question.
Yeah. I mean, what's short of going into the document and seeing who's in the share list, you want to see a sort of report of things.
Yeah.
Yeah.
That's what I think the question is. Yeah, I think you would have to go one by one. Yeah, I don't think there's a way to generate a report of shared.
That's a good question. Yeah.
Can I send PDF files or photos when I contact support? Well, you can take a screenshot directly of it, and then you can always attach emails, or you just attach things to emails.
So once the ticket is opened, right? Yeah.
Yeah, what will happen is, like, when you submit a support ticket, they will send you an email. You can reply to that email with anything you like. Yeah. And it's just an email attachment at that point. So yeah, that should work. What are the plans with CAM integration? This is something we get asked often.
Yeah, I mean, we have partners there. We have you know, App Store type of approach right now. You know, we're continuing to monitor that sort of situation, and you know, there's really nothing more to report on in that area right now.
Well, the one thing I would say is we really do take your feedback seriously, and so if CAM is a huge thing for you, please let us know if you haven't already, in the form of a support ticket. Okay, we are just about out of time, and we have just a few comments here. So I think we will wrap things up.
Yeah.
That was it for me. Greg, do you have anything else?
No, other than to say thank you. I think it's been valuable. It's been fun. I've enjoyed being here, or virtually here with Cody and everybody else. And I encourage you, if you enjoyed it, to give us some feedback, and we will do it again in a few months' time. Thank you very much.
Thanks, everyone.
Yeah, bye.